For this arrangement of resistances, we have to find the equivalent resistance as seen from here, or the resistance, in short, the resistance seen from here. So we have to replace the whole arrangement with just one resistance. So in order to do that, we should start from here, this side, and we can see by looking at it at first glance that this one, and this one, these three resistances, the 4 ohms, 5 ohms and 3 ohms, these three are in series. So the equivalent of these three will be, they will be added, 4, 5 and 3. So what we will do, we will draw the rest as they are. So that's 4 ohms here, 6 ohms here and 3 ohms there, then 3 ohms and 4 ohms, and these three will be added and will be, the two terminals will remain the same, so it will come here, and the equivalent value of these three series resistances will be just addition, 4 plus 5 plus 3, that will be 12 ohms, and this is 4 ohms. Now when we see here these two, we can see that these two are in parallel. So as we discussed in the previous video, the parallel equivalent of two resistance, we can use just that formula, which is Rp. When Rp is equal to R1 parallel R2, the equivalent value is R1 over R2, R1 times R2 over R1 plus R2. So basically this is this comes from this one, 1 over Rp is equal to 1 over R1 plus 1 over R2. So from this we get 4 times 12 divided by 4 plus 12. 4 times 12 divided by 4 plus 12, which will be 48 over 16, that's 3 ohms. So now we will again draw the remaining part as it is. So 4 ohms, 5 ohms, 4 ohms, 6 ohms, 3 ohms, 4 ohms, 6 ohms, 3 ohms, and then this one will be that 3 ohms, and the new resistances, maybe I will draw in a different color, this will be 3 ohms. This is the parallel equivalent, 3 ohms. So these two again now in series, we can see that 3, 3, these two are in series, so that will become 6. So this one, this part remain the same, 4 ohms, 6 ohms, 3 ohms, and these two added becomes 6. Now when we have parallel of two equal resistance, two same value resistances are in parallel, the equivalent value will be half of that. We can just check here, 6 times 6 over 6 plus 6, that will be 36 over 6, that's 3. It's always for any case, 2 parallel 2 will be 1, 10 parallel 10 will be 5, like that. So here the parallel of these two will be 3. So we have 4, then 3, then 4 ohms, 3 ohms. This is the parallel equivalent, and that's 3 ohms again. So these two 3 ohms, that's coming here. Now this is the resistance. Now it's much simpler, and what we see now, these three resistances are in series. So we just add these three, that will be the equivalent resistance. So the whole thing can be replaced by just one series resistance. That will be the addition of these three, so 10 ohms. So the resistance seen from here for this circuit is 10 ohms. The result is 10 ohms, and this is how we find the equivalent resistances. These are still series and parallel arrangements, but we will encounter different kind of arrangements later as well. But this is just the series and parallel arrangements.